Now we can see from here the relation between N and L. Let me write it again, that N here is equal to J maximum plus L plus 1. Now the L is equal to N minus 1 minus J max. Now here, if I take f L is equal to N, then what will happen? That 1 is equal to 1 minus 1 minus J max, and 1 is cancelled with 1, and this gives that J max is equal to minus 1, means it is negative. Now J is a number, and J is the minimum value of it is starting from 0, and it goes to infinity here. So it can never be negative, it will be a very high number. So it means that this thing is not possible. L equal to N is not possible. Then what can I write here? That L, if L is, if I consider L not equal to N, but L less than N, then what will happen here? When L is equal to N minus 1, J maximum, let me write it in this form. L plus J maximum is N minus 1. So J is a value which is running from 0 to the maximum value. So if I put its minimum value possible, then L will be equal to N minus 1. And this gives the maximum limit of L. When J will be greater than 0, then L will become further less than N, because it will come here minus J max. So for J max equal to 0, we will have the maximum value of L, and for J max, J value any more than 0, we will have L value much less, we will have L value even less than N minus 1. So this means that, as we have proved earlier, that L is a positive integer through our mathematics. And we came to know about N as well, that N is a number. We don't know at the moment that what will be the values of it, but N is a number, and the maximum value that L can have is N minus 1 values this L can have. So its values, when it is 0, 1, 2, 3, 4 and so on, its maximum value will remain N minus 1. It cannot be equal to N. So here we are having this restriction on the value of L. So from this equation, I can now write that 2 times N is equal to rho naught. So this implies that 2 times N is equal to rho naught. And now I will have to put the value of rho naught, and rho naught I have supposed that this is equal to rho naught was m e square divided by 2 pi epsilon naught, 2 pi epsilon naught h bar square k, where k was equal to minus 2 me over h bar. So from here, E is equal to h bar square k square over 2m with a minus sign, and this is equal to, so put the value of k here from here. So I will write in the rho naught value from here. So k from here will be minus h bar square over 2m, and the k square value from here is m e square divided by, because if I want to write the value of k from here, then k is equal to m e square over 2 pi epsilon naught h bar square rho naught. So this will be m e square over 2 pi epsilon naught h bar square rho naught, and this is whole squared. And if I put for rho naught to n, then I will get that E is equal to minus m over 2h bar squared and E squared divided by 4 pi epsilon naught whole squared and 1 over n squared. Now this value that I have here, from here to here, this value I term is E1, and our IKM term is E0, is normally it is done, but this is E1. So I have that E, let me write this is En, and En is equal to, if I write for this E1, then it is divided by n squared. Now from our mathematics, this is E1 being the energy, which is a constant, and it is m is constant, h bar, E and epsilon naught pi, all these are constant. And if I calculate this E from here, that this is me4 divided by 2 h bar square, and here this will be 16 pi square epsilon naught square. If I put mass of electron here, for E I put the electronic charge, the h bar value, epsilon naught value, all this, I will get that this is 13.6 electron volt, and which I call is the ground state energy of the hydrogen atom. So this is E1, and what will be the value of this? So let me call this value is E0, which I will call is the ground state energy. So let me call this is R. Why not to call this is with a subscript G for ground state. So this will be the ground state energy, and here E ground. Not to confuse this thing with the band gap energy, that one is with the small g. So I can write that this is minus Eg over n square. Now for what should be the value of n? N cannot be 0 because any other higher energy will become undefined. And I can write from here that this n should start from 1. Now, the starting value cannot be 0. The starting value should be 1. And from here, whether the next value will be a fraction or any other non-zero value, we will have to come back to this equation. And this equation is that n is j max plus L plus 1, or here L value is 0 or 1, 2, 3, 4. J max value is 0, 1, 2, 3, 4. So from here, let me write that n is j max plus L plus 1. Now, the minimum value possible for n here is j max. So j can start from 0 to any maximum value. So the initial value of it is 0. The n initial value is 0. And here I am having 1. So the n initial value is 1. Now for any other value, 1 here, then when n is 0 and j is 1, or take the value of L1 and the value of J0, so we will have n equals 2. Similarly, when L is 0, J is 1, so we will have 3 and so on. So whatever the values of n are, they are positive integers, excluding 0. 0 is not possible, as we checked here and is evident from here as well, but our main condition is on this one. So this tells us that n should be 1, 2, 3 and so on. Is there any maximum limit on n? So no, because there is no maximum limit. There is a maximum limit on L, that it will be n minus 1. So 1 will cancel with 1 and n will cancel with n, but j will start running. So we will have that there is no maximum limit on n. Similarly, for n equals 2, we are having the energy E2, the ground state energy Eg by 2 square. So we will have 4 here, and if I divide 13.6 by 4, I will get 3.4 electron volt energy, which is the first excited state of hydrogen atom. This one is non-degenerate, while this one is a degenerate energy, which we will discuss later, that what is meant by degenerate and non-degenerate. So our mathematics told us that n should be 1, 2, 3 from that relation, and with this we have calculated the energy of the hydrogen atom, the ground state energy and the first excited state energy, which exactly match with the experimental values, and that's why solution of the Schrodinger wave equation is giving a direct mathematical proof for the experimental result. We haven't done any assumption, only we have done mathematical tricks or mathematical solutions. Now, if one is wondering that why when we approximated so many things and we got very accurate result here, then these results are actually the very surface results. For this detailed calculation or all those calculation of reduced mass and the psi as a function of r and t that are not required, these are very surface information, and the surface information can be obtained by even approximating the results. So we started with the hydrogen atom and we solved the radial equation, and we have already solved the angular equation, and for angular equation the hydrogen potential or the Coulombic potential wasn't required, so that solution will be valid for the hydrogen atom as well, as that is the angular solution. Now we know that in hydrogen atom we have considered a spherically symmetric potential, and our angular equation is also spherically symmetric. So I can write that the wave function which I have is a function of r, theta and phi. Now different quantum numbers were involved. From the radial I get n and l, and from the angular I got l and m. So my wave function will be psi n l m. If even I skip the commas between them, then it's right. N, L and M is equal to the wave function, which was only r dependent, means the in r theta phi it was only r dependent. This is that wave function, which is a function of r, and it caused two quantum numbers to be calculated for this one, which were n and l, and the angular wave function, which was y, and it was a function of theta and phi, and it involved two quantum numbers L and M. So this was the spherical harmonic that we derived. So this will be the total solution of our wave function. Now it's coming back to our R and L, and our R and L is equal to, we have written our solution, and our solution was that 1 over R here, R and L. Now here we have written U of rho here. So the U of rho is actually, we know the relation between the R and U is U was equal to R. So if I want to write R, then I will have to write it the solution of U divided by R. So I will put 1 over R and then the solution of U, and the solution of U is E minus rho, and rho to the power L plus 1 and nu of rho. This is my radial wave function. So I will have now to put the values here. This gives me a recursion relation, and the recursion relation was 2j plus L plus 1 minus rho naught, and rho naught we proved that this is equal to 2n. So if I put 2n here and I take 2 as a whole common, then this I will write j plus L plus 1 minus n. So the recursion relation becomes Cj plus 1 is equal to 2j plus L plus 1 minus n, and divided by